more information than significant tests. The significant test just kind of gives you a yes or no. You can reject or fail to reject, but you don't still know what the actual proportion or actual mean really is. So a confidence interval might shed some light on this issue. So there was a example that we did early on in this chapter. They were checking to see if the proportion of first digits were significantly different from what they had expected. If you remember when we did this, the null was that the proportion was equal to 0.301. The alternative was the proportion was not equal to 0.301, and we made the decision to reject the null. So we rejected the null, and we said the proportion was different than what we had expected. So we learned, but we still, even though we decided to reject that and we said that it was different from that, we didn't know what the actual proportion was. So when we can do a confidence interval to get some light on, to understand that a little bit better. So if I went back to this problem and I calculated the 95% confidence interval, there's my first step. I'm doing a one sample z interval proportion. The problem was random. I'm going back to using that p hat because I'm talking about a confidence interval. There's at least 3,000 records. I find the interval, and then I'm 95% confidence the interval 0.17929 to 0.27404 captures the proportion of expenses that have the first digit of 1 for this company. So I believe that the interval, the proportion of 1 is somewhere in that interval right there. So I know that that is different from 3.01. So based on the interval alone, should the company be investigated for fraud? So I could say yes, because 3.01 is not in the interval. So it does seem possible the company, it doesn't seem possible that the company could equal this value. And what I mean there is that it doesn't seem possible that the 0.301 of the numbers start with the digit 1. So basically what happens here is I can take a two-sided test at a significance level, and I can carry it out directly from a confidence interval that has the confidence level 1 minus alpha. So if I had a 5% significant test in this problem, if I do 1 minus alpha, so 1 minus 5%, I can carry out the same test through a 95% confidence interval. So the confidence interval in two-sided tests. So a level alpha two-tailed significant test rejects the hypothesis P equals P naught when P naught falls outside a level 1 minus alpha confidence interval for P. So again, in that example, the 3.01 was outside the interval, so I could reject it. These are the hypotheses. So you're only doing this, you can only do this comparison between the confidence intervals and two-sided if you're doing a two-tailed test here. There are one-sided confidence intervals, but we don't cover that in this course. You could also apply this rule of the means. All right, so I can carry this out here with a two-sided test of means as well. But that's basically the idea of this section here, is just to show you how you can use a confidence interval, a two-sided one, or a confidence interval to carry out a two-sided hypothesis test. And that's it.